I like to look at problems 117 and 118. We're given a function. I'm copying it. I'm going to copy p of x. They want p of x. So sorry about that. I wrote f of x also. It's 95 minus 30 log base 2 of x. So the function models a percentage p of x. I'm taking notes. Percentage of students who could recall the important features of a classroom lecture as a function of time, where x represents the number of days that have elapsed since the lecture was given. So x number of days. The figure at the top, which we have, I'll show it in a minute, of the next column shows the graph of the function. Use this information to solve exercises 117, 118. Round answers to one decimal place, they say. 117. After how many days do only half of the students recall the important feature of the classroom lecture? Locate the point on the graph. So please tell me what we need to do. After how many days, which means how much is x, find x, the percentage or only half of the students recall the features, the important ideas in the lecture. So how do I solve that? That's number 117. Right, percentage. Well, I'm assuming the percentage, I know it's a very good point you're making, Heather. Normally, we do not use percent in an equation or a function. However, in this case, we're told that p of x is given in percent. Yeah, but you're right. Normally, we do not use percent, but this time they say, that's why I took notes, so I know what they mean. So then 50 equals 95 minus 30 log base 2 of x. Okay. Now, of course, I'm going to ask you what type of equation is it, because if we identify it correctly, we have great chances to solve it correctly. What type of equation is it? It's a log equation. Very good. Once you see a log in there, unless it's a combo. Good. We have to completely clean that up. So what will I have to do first? Subtract 95. So negative 45 equals negative 30 log base 2 of x. Perfect. I subtracted 95 from both sides. Negative 95 plus 50 is negative 45. Perfect. One more step towards cleaning it up. We divide both sides by negative 30. Good. So then we have log base 2 of x equals 45 over 30. And we should simplify it by 3. So log base 2 of x, and of course x has to be greater than 0. We're talking about number of days. It cannot be negative. That's why I didn't state the restrictions from the beginning, because x must be positive. Okay. So what do we have here? By 3, 15 and 10. And again by 5, right? And I get 3 halves. Good. I should have simplified by 15 from the very beginning. Okay, so perfect. I don't know what this is, but I know that I can change it very easily into 2 raised to, yes, 3 halves equals x. So x equals basically the square root of 8. It's a number greater than 0. But I have to take the square root of 8, because I cannot tell you that I have in my pocket the square root of $8. I'll have to approximate it. So we want to determine how many days approximately will pass till only half of the students remember the most important features of the lecture. So what did we get? X is how many days?
2.83.
Okay, so approximately 3 days. Approximately 3 days. Okay, perfect. Part B, or 118. After how many days have all students forgotten the important features of the classroom lecture? So after how many days nobody remembers anything from that lecture? What does that mean? The percentage is 0. So then 0 equals 95 minus 30 log base 2 of x. We know what type of equation this is. It's log, and we want to determine after how many days, based on this model, after how many days nobody remembers the important features or lecture topics. So what would you say? Yes, or I bring this in so I don't have to multiply by -1. So 30 log base 2 of x equals 95. Then I need to clean it up. At this stage, I cannot change it into an exponential. Yes, I have to divide by 30. So log base 2 of x is 95 divided by 30. If I simplify by 5, I get 6 in the denominator and 1/9. Good. So now let's change this into an exponential equation. Very good. Equals x. And now I'll approximate with a graphing calculator by taking 2 to power 19 divided by 6. And that is about 9 days. Kind of depressing. So about 9 days after the lecture is presented, according to the model, almost everyone in the class would have forgotten the major topics. Well, I hope that's not the case. I hope the model is wrong. Okay. The last section of chapter 4 deals with applications. You do not have to memorize any models. All these models will be given to you. So let me list the models that we are going to look at. Number 1 and number 2, we already looked at. A equals P e to RT. This is continuous compounded interest. This will be given to you. A equals P, 1 plus R divided by N raised to NT. This is interest compounded N times per year. Of course, it will be given to you. 3. Logistic growth model. It will be given to you. I'm just going to give you the general formula, but you do not have to memorize any of this. So for example, f of x equals a divided by b plus c e to negative k x, where a, b, and c will be given to you, and k as well. They're constants. 4. Exponential growth model. A equals A0 e to kt. Exactly the same type of model with this one, just the letters are different. Identical. And I promise the last one, number 5, exponential decay model, where m of t, I should have put also here a of t, m of t equals m0 e to negative kt. I'll explain again each and every one of them when we apply them in word problems. The first two are done, because we've done those at the beginning of this chapter. We looked at continuous compounded interest. If we want to pick another, we can. We looked at something like this with the interest compounded n times a year. We can pick another, of course. I'd like now to look at a logistic growth model. Page 531. Let's start with problems 43 through 46.
Can you go back up?
They are the same. It's just the notation is different. Is that okay?
No, I think the. Oh yeah, that's one.
Okay, so the logistic growth function is given to us in problems 43 through 46. And that is p of x equals, is this okay? P of x equals, the numerator is 90, 1 plus 271 times e to negative 0.122x. As I said, the model will be given to you. What is A in this model? 90. What is B in this model? 1. What is C in this model? 271. What is K in this model? 0.122. You don't have to memorize any of it. Okay, so let's answer the first question. What percentage, let me explain what that all means. So the logistic growth model models the percentage, P of X, percentage of Americans who are X years old with some coronary heart disease. So X is the age. The percentage means at a particular age, such and such percentage, according to the model, have some heart problems. Coronary heart disease. Use the function to solve exercises 43 through 46. What percentage of 20-year-olds have some coronary heart disease according to the model? So that's 43. Among the 20-year-olds, what is the percentage? How do I determine that? What do I have to do?
20.
Yes, of course. So P of 20 is 90 over 1 plus 271 times e to negative 0.122 times 20. So we need the graphing calculator for this, so let's do that. Here it is. 90 divided by, in parentheses, 1 plus 271 times e raised to the power, in parentheses, careful, negative 0.122 times 20. Close the parenthesis for the numerator, the power, and then for the denominator, and press enter. About approximately 4%. And this is expected. At 20 years old, no one should have any issues with the heart. So this is expected. 44. What percentage of 80-year-olds have some coronary heart disease? So what do I do now? Good. So you go back. Do not erase what you had. So just go back and change 2 into 8. Exactly. And press enter. Do you expect the percentage to be higher? Yes. Okay, look at that. Approximately 89%. So it's quite high, right? Okay. Next one, 45. At what age is the percentage of some coronary heart disease about 50%? So 44, 45 now. At what age is the percentage 50? In other words, roughly 50% at that particular age group, from that particular age group, have some coronary heart disease, and the rest do not. So what am I going to do next? Say it again. Which one?
15.
Equals 90 divided by 1 plus 271 e to negative 0.122 x. This 50%. I'm sorry?
When you put 50 there, it's x is equal to h.
We don't have it. We don't know the age group for which the percentage is 50. In the previous two examples, we were given x, we were asked to find the percentage. Here, we're given the percentage, we're asked to find x. This is not a trivial equation. It is not even pure exponential. It's exponential combined with a rational. But still, here's what I see. I still see this. What you see in the denominator is just noise, right? Just something in there. We don't care. It's still a proportion. How do we address this? What do we have to do with the proportion? Always cross multiply. So we have 50, do not distribute. In parentheses, 1 plus 271 e to negative 0.122x equals 90 times 1, which is 90. We have to get to e, slowly but surely. What will you get rid of next?
So divide by 50.
Divide by 50. Very good. That's the point. That's the next step. So 1 plus 271 e to negative 0.122x equals 9 over 5. Excellent. 90 over 50 is 9 over 5. Okay. How do I clean it up next? Slowly but surely. What do I get rid of now? Of 1. 1 has to go away. So I move it to the other side. 9/5 minus 1 is 4/5. So 271 e to negative 0.122x equals 4/5. One more step to clean it up. Divide both sides or multiply both sides by 1 over 271. These go away. So you have e to negative 0.122x equals 4 times. Do not perform any operation. We don't care about that product. You can stay as is. You can multiply. There's nothing wrong. Now it's completely cleaned up. I have an exponential equation, e to a power that has the variable and a number on the other side. What do I do next? Now I'm ready for something that brings the power down. Bring the power down, applying what to both sides? Very good. Exactly. So this is negative 0.122x times natural log e. But what is natural log e? Very good. Equals natural log of 4 over 5 times 271. What would be the final step? This over negative 0.122. The top is natural log 4 over 5 times 271, and the denominator is that. Ready? We have to be very careful how we put this in the graphing calculator, please. Let's do it together. I have a calculator here if you want to try it. Okay, so the top, natural log. Top of inside of the natural log 4 divided by, please put parentheses around the denominator, which is 5 times 271. 5 times 271, close the parenthesis, and then close the parenthesis for the entire log. And then divide by, in parentheses please, negative 0.122. Close the parenthesis and press enter. So it appears that approximately at what age, according to the model, about 50% of the people at that age have some heart issues. 48. So it appears that approximately at 48 years of age, they have, according to the model, some coronary heart disease. I know there are only 2 minutes left. I don't think I can show you anything quickly in 2 minutes from the word problems. I cannot say that chapter 4 is done because it's not